deep dive. Today, we're going to be tackling kind of a fascinating question.
Yeah.
How do we learn language?
Mm-hmm.
Is it something that's special to humans?
Yeah.
Or can artificial intelligence
Right.
learn just like we do?
Mm-hmm.
And we're going to be going
Yeah.
beyond your typical language learning app, Duolingo and Rosetta Stone.
Right.
We're venturing into the territory of impossible languages.
Okay.
These are linguistic creations that break all the rules that we find in human languages,
Right.
resulting in sentences that might sound like a blender exploding.
Okay.
Our guide for this deep dive is a
Yeah.
thought-provoking article from Quantum Magazine called "Can AI Models Show Us How People Learn? Impossible Languages, Point Away."
Okay.
We're also going to touch on the ideas of Noam Chomsky, who had some pretty strong opinions about AI and language.
Yeah.
So buckle up and get ready to explore the fascinating world of language and learning.
It's a truly mind-bending journey.
So let's start with Chomsky.
Okay.
He believed that humans have this innate ability to learn languages.
Right.
Like our brains are pre-wired with a specific set of grammatical preferences.
Yeah, that's right. Chomsky's theory suggests that certain languages are impossible for humans to learn because they violate those fundamental rules that are ingrained in our minds. He believed that AI, on the other hand, could theoretically learn any language, even ones that make absolutely no sense to us. In his view, this difference made AI a less useful tool for understanding how real language acquisition works.
So tell me more about these impossible languages.
Sure.
How are they created? What do they sound like?
Researchers got creative. They started with a normal English text database and then scrambled the sentences in various ways. Imagine taking a sentence like, "The quick brown fox jumps over the lazy dog," and turning it into, "Brown quick the jumps fox over lazy the dog," by shuffling the words in groups of 3. Whoa, that's wild. It's like taking a perfectly understandable sentence and putting it through a linguistic blender.
Exactly, and it gets even more bizarre.
Oh, no.
They created a language called random shuffle, where the word order is completely jumbled. Like throwing all the words into a blender and hitting puree.
So it's like
the information is still there.
It's completely unintelligible.
But it's like trying to solve a cryptic puzzle.
So how did researchers test whether AI could actually learn these scrambled languages?
Julie Collini and her team at Stanford took on the challenge. They used powerful transformer AI models similar to the technology behind ChatGPT and pitted them against each other. Some AIs were trained on these impossible languages while others learned normal English. They wanted to see how each model learned and how accurately it could predict the next word in a sequence. Kind of like how our phones predict what we're typing.
So it was like a linguistic Olympics.
Yes.
With AIs competing to see who could crack the language code.
Exactly. What were the results? Did the AI learning English have a clear advantage?
As you might expect, the AI trained on normal English aced its tests.
Okay.
It learned quickly and became quite good at predicting the next word. But here's where things get really interesting.
Okay.
The AIs trained on those impossible languages did in fact struggle.
So does that mean Chomsky was right?
It's not that straightforward.
Okay.
The AIs learning the scrambled languages were much slower and made more mistakes. It was like they were stuck in remedial class while the English AI was breezing through advanced coursework.
Yeah.
This suggests there might be something unique about how human brains process language.
But didn't you say there was a twist?
Right. One of the impossible languages, called word hop, threw everyone for a loop. The AI trained on word hop learned almost as well as the model trained on normal English.
Hold on, word hop. Remind me what made that one special.
Word hop had a strange rule for marking plural verbs. Instead of adding an S at the end of the verb, it used a special character placed 4 words after the verb.
Okay. My brain needs a moment to process that. But it's fascinating that the AI didn't completely stumble on this one.
It did.
Does this mean Chomsky was wrong?
It's more nuanced than that. The fact that the AI struggled with most of the impossible languages suggests Chomsky might have been onto something. It seems AI does have limitations. And studying how it learns could give us clues about how our brains work.
So maybe we're not so different from these machines after all.
Perhaps not, but the word hop example adds another layer of complexity. It demonstrates that AI can learn unusual rules, even ones that seem completely foreign to us humans.
But only under certain conditions, right?
Exactly.
So what?
Word hop, despite its odd rule, maintained a level of logical consistency. The AI could still find patterns and make sense of them, even if those patterns were different from what it would find in regular English.
So the takeaway here is that it's not just about whether a language follows typical rules.
Right.
It's also about how the information is presented within the language itself.
That's a great way to put it.
What do researchers call that concept again?
Information locality.
Information locality.
Both AI and humans seem to learn better when the information is presented in a way that makes sense to our brains.
It's like trying to read a book where the sentences are scattered randomly across different pages.
Exactly.
Total chaos.
It appears that AI, with all its impressive abilities, might have a similar sensitivity to how information is organized. If things get too jumbled up, it struggles to connect the dots and make sense of it all.
This is incredibly interesting. Before we move on to the researchers' next steps, let's take a closer look at the specific impossible languages they created and how the AI models performed against them.
Let's delve deeper into how these impossible languages were actually put to the test.
Yes, please. You mentioned that researchers used transformer AI models.
Right.
But what does that mean exactly?
Think of transformer networks as the brains behind AI models like ChatGPT.
Okay.
These networks are designed to process language and learn patterns. In this case, researchers chose to use smaller transformer networks, kind of like a mini version of those massive models we hear about all the time.
Why use a smaller version?
They believed these smaller networks might be more sensitive to the weirdness of the impossible languages.
Okay.
Compared to their larger, more complex counterparts, it's like using a more finely tuned instrument to detect subtle differences.
Interesting. So how did they set up the experiment?
Okay.
Did they just feed the AI these jumbled sentences and see what happened?
It was more structured than that.
Okay.
They trained each AI model on one specific language, either normal English or one of those creatively scrambled impossible languages.
Okay.
As the training progressed, they would check in on the AI's progress.
Like giving them pop quizzes to see how they were doing.
Exactly. The quizzes were designed to test the AI's ability to predict the next word in a sequence.
Okay.
It's similar to how your phone tries to guess what you're typing in a text message.
Oh, yeah, like when my phone suggests pizza, because let's be honest, it knows me too well.
Precisely.
Yeah.
So, unsurprisingly, the AI model that trained on normal English performed exceptionally well.
Okay.
It learned quickly, aced its quizzes, and became very good at predicting the next word.
But the AIs learning those impossible languages,
Right.
They didn't fare so well, right?
Not quite as well, no.
Okay.
They definitely lagged behind.
Uh-huh.
The impossible languages seemed to throw a wrench in their learning gears. They were much slower to learn, and their word predictions were less accurate compared to the English-trained model.
So it seems like even for AI, learning a language where the words are all jumbled up is like trying to solve a ridiculously difficult puzzle.
That's a great analogy. However, remember that word hop language we talked about?
Right.
The one with the peculiar rule for plural verbs?
Right.
Well, the AI trained on word hop actually performed almost as well as the model trained on normal English.
That's right. I'd almost forgot about that.
Yeah.
It seemed to defy all expectations.
It did, and it highlights a crucial point.
Okay.
It's not simply about a language following the typical rules we see in human languages. It's also about how the information is structured within the language itself.
Okay.
Word hop may have been unusual, but it maintained a certain level of logical consistency.
So the AI could still find patterns and make sense of the information even though the rules were different.
Exactly. Word hop might have had a strange rule, but that rule was consistently applied, allowing the AI to make those crucial connections.
Okay.
It reinforces the concept of information locality, which we discussed earlier.
Right.
The AI, much like us, seems to learn better when the information is presented in a clear, organized way.
It needs those clear connections to extract meaning and make sense of what it's learning.
Right.
Otherwise, it's like trying to read a book with pages out of order.
Precisely. And that brings us back to Chomsky's initial claim.
Okay.
He believed that AI could learn any language regardless of how nonsensical it might seem to us.
So did this research prove him wrong?
The findings are more nuanced than a simple yes or no.
Okay.
Remember, most of the AIs did struggle with the impossible languages, suggesting that there are limits to their learning abilities.
Which lends some support to Chomsky's idea that there's something unique about how humans learn language.
Yes, but the word hop example complicates things.
Okay.
The AI's ability to learn this unusual language, as long as the information was presented logically, suggests AI is more adaptable than we might have initially thought.
So it's not a clear-cut case of humans versus machines.
Not at all. This research is less about crowning a winner and more about understanding the different ways in which humans and AI approach language. The fact that AI is sensitive to the structure and organization of information might reveal something fundamental about how all intelligent systems, whether biological or artificial, learn and process language.
It seems this study opens up more questions than it answers.
Right.
What did the researchers have to say about these seemingly conflicting results?
Yeah.
Did they think they had solved the mystery of how we learn language?
They were actually quite excited about the complexities that emerged.
Why is that?
Well, because those complexities paint a richer and more realistic picture of language learning.
Okay.
It's not a simple process that can be easily replicated in a machine.
So this research, instead of declaring victory for either team human or team AI,
Right.
is actually helping us understand the strengths and limitations of both.
Exactly.
It's like peeking into the inner workings of both biological and artificial minds.
Exactly. And that's what makes this research so intriguing.
Yeah.
It's not about finding a definitive answer. It's about expanding our understanding of what's possible and pushing the boundaries of what we know about language learning and intelligence itself.
This is truly fascinating. So what's next for these impossible languages? Is this research just going to stay within the theoretical realm, or could it have practical applications in the future?
It's definitely not just a theoretical exercise. The researchers are already planning follow-up studies to explore the practical implications of their findings.
Okay.
One of their main goals is to investigate whether tweaking the design of AI models could improve their ability to handle these unusual languages.
So they're essentially trying to make AI more impossible language friendly.
Exactly. They want to go under the hood, so to speak,
Yeah.
and see if they can re-engineer the AI to overcome the limitations highlighted by this research. Imagine an AI that can learn not only human languages, but also decipher alien languages or crack ancient codes.
That sounds like something straight out of a science fiction movie. But let's bring it back down to earth for a moment.
Sure.
What kind of real-world impact could this research have?
Think about machine translation.
Okay.
Imagine AI that can seamlessly and accurately translate between languages, capturing all the nuances and subtleties that are often lost in current translation systems.
That would be revolutionary. No more awkward or inaccurate translations.
Precisely. But the potential benefits go beyond just improving existing technologies.
Yeah.
Imagine using AI to personalize language learning, creating custom programs tailored to individual learning styles and preferences.
It would be like having a personalized language tutor guiding you every step of the way.
And who knows, maybe this research could even lead to the development of entirely new languages.
Oh.
Language is designed for specific purposes like scientific communication or computer programming.
We could be creating the languages of the future. That's an incredible thought.
It is.
But you also mentioned that researchers were interested in comparing different kinds of impossible languages.
Right.
Why is that important?
Remember how the AI struggled with most of the impossible languages except for word hop?
Right.
Well, researchers want to understand why word hop was easier to learn.
Okay.
They plan to create a whole library of impossible languages, each with its own set of unique rules.
So it's like setting up a series of linguistic challenges
Yes.
to see what AI can handle and what trips it up.
Precisely. By comparing how the AI performs on these different challenges, they hope to gain a deeper understanding of the underlying mechanisms of language learning in both machines and humans.
It's fascinating how studying AI can teach us so much about ourselves.
Right.
It's like holding up a mirror to our own minds.
Yeah, it really is. And this research highlights the importance of interdisciplinary collaboration by bringing together linguists, computer scientists, psychologists, and others. We can gain a more holistic understanding of something as complex as language.
This has been an incredible deep dive.
It has.
We've learned that AI might not be the ultimate language wizard we once thought it was.
Right.
And there might be something unique about how humans learn and process language.
Yes. But we've also seen that AI is capable of surprising us.
Yeah.
Learning unusual patterns and pushing the boundaries of what we thought possible.
It seems like the world of impossible languages is more than just a theoretical curiosity. It's a window into the future of language learning, communication, and perhaps even our own understanding of intelligence.
Well said. If you're interested in delving deeper into this fascinating topic, I highly recommend checking out the full article from Quantum Magazine.
And to our listener, as we conclude this deep dive, I'd like to leave you with a thought-provoking question. If AI can learn some of these unusual language rules, even if it struggles with others, could we potentially design new, more efficient ways for humans to learn languages? Could we leverage these insights to unlock new levels of fluency and understanding? It's something to ponder as you continue your own exploration of language and learning. Thanks for joining us on this incredible journey into the world of impossible languages.